Assalamu alaikum everyone. Welcome in the new lecture. I hope everyone is fine at home and you have already done the homework. So today we will continue our previous lecture. So if you remember last time we were discussing limit. So today I will continue in the same way. So today we will start it is your practice sheet number 4. So from that, question number 2. The question number 2 is, by considering different paths of approach, show that the following function have no limit. Now here the question is very clear. So what we have to prove? We have to prove this function have no limit. If you remember your calculus 1 course, in calculus 1 course you also solved the limit problem, and then sometime limit exists and sometime limit does not exist. In that case, if you remember in calculus 1 course, when you solve the limit problem, you take the left hand limit and sometimes you take the right hand limit. If left hand limit and right hand limit they are not same, then you say overall limit does not exist. And so here we will apply almost similar concept but in different way, because now we are doing multivariable calculus. So we will instead of doing left hand limit and right hand limit, what we will do, we will introduce here different paths. So that is why you can see here it's written by considering different paths of approach. So what paths of approach we will consider? So here we will consider, if I jump to example number third part of the practice problem. So we can consider path y is equal to mx, we can consider y is equal to mx square, we can consider y is equal to mx cube. So in our this course, we will consider these three A paths. So if for example first path y is equal to mx, say limit exists, so it means now the question was you have to prove limit does not exist. So we will move to the second path, y is equal to mx square. If still limit exists, then you can move to the third path, which is y is equal to mx cube, and then you will check limit exists or not. So how you will check limit exists or not? If for example you solve the question and at the end you get some here real number, so it means your limit will exist. But if your final answer is in m, if your final answer is in m, so it means then limit will not limit does not exist. Why? Because m is any real number, so we can for different values of m, so this can be a different answer. So it means it will not be a unique number. So you know from calculus 1, if your function is given two different limit. So if you approach from one side, it gives say 1, and from the other side it gives answer as 2. Then we say your left hand limit and right hand limit, they are not same, so limit does not exist. So here we also use the same concept, but we are using different paths. So if here the final answer is in m, it means for different values of m we get different answer. So it means we will say limit does not exist. But here if at the end say we get only a number, it means just like I get only 2, 3, there is no m. So it means for any value of m this will not change. So it means then we will say limit exists. I think now it is clear. So I will first solve this third part. So here the question, limit xy goes to 0, 0 minus x over x square plus y square square root. So now I said always start with the first y is equal to mx, and then you can move to the other path. So then if what I will do, so I will substitute instead of y, I will put here mx. So I put y as mx. So then this will be minus x over x square plus because mx whole square, so it will be m square x square. So that is equal to minus x over x square. I can take from here common, so it will be 1 plus m square, and then x square, if it will take you take square root of this, so this square and square root will cancel, so it will be only x, and 1 plus m square will be in the square root. Now this x and x will cancel, so this will be then minus 1 over 1 plus m square square root. Now, so therefore, now if you take limit on both sides, limit on this side and limit on this side, so it will be limit xy goes to 0, 0 f of xy over x at y is equal to mx. So here you can see no xy. So I will not substitute any value. If for example here some x comes or y comes, then I will put value of x and y. So here you can see there is no x or y. So it means I cannot put any value of x or y. So the final answer is m. So for different values of m will give different limit values. So limit does not exist. I hope it is clear. Now I will move to the first example. So what you will do in this example, again this is your homework. So you will check yourself y is equal to mx path, and we will see if you will put here y is equal to mx path, the limit will exist, and at the end here you will get some real number, and we have to prove limit does not exist. So I already know limit does not exist for this. So for y is equal to mx square, so I will take this path y is equal to mx square. So if you substitute instead of y in this function, instead of y you substitute mx square, so it will be 3x square, y as mx square, x square minus 5 square root, and y is your mx square whole square. So you simplify this, so this will be 3m, x square and x square when multiplied will be x4, and x4 minus 5 square root, so this will be m square and x square power 2, so this will be x power 4. Now you can take here from this you can take x4 common, so then it will be 1 minus 5 square root m square, and this x4 and this x4 will cancel, so it will be 3m over 1 minus 5 square root m square. Now you can see here very clearly there is no x, there is no y, and if even you substitute limit xy goes to 0, 0, so it will not change. So we will get this answer 3m over 1 minus 5 square root m square, and for different values of m we will get here different answer. So that is why we are saying limit does not exist, and I have written here also as the limit changes for each value of m, that is if we take m is equal to 1, then the limiting value is this. If I put here m1 you will get this, but if we take m0 then the limiting value is 0, because if I put here m0, so 0 by 1 minus 0, so it will be 0. So it means for different values of m we will get different number. So therefore limit does not exist, because the limiting value of a function is always unique. There is the rule that I was already explaining. So whatever the path we approach, the limiting value should come same. Okay, if I, as I said, if I take y is equal to mx path, or if I take y is equal to mx square path, or if I take y is equal to mx cube path, for all paths if we get same number, it means we get some real number, a unique number, then limit will exist. If we get final answer as m, so then limit does not exist. I hope this is clear. Now the third part I already solved, and now there is fourth part. So again you can apply the same rule. Limit xy goes to 0, 0, 9x power 4y, x power 6 minus 3 square root y cube. So again you can check with y is equal to mx, and then you can move to y is equal to mx square. So I directly start y is equal to mx square just to save the time. So if you again put instead of y as mx square, so this will be 9x4 mx square x6 minus square root 3 mx square, and then y is cube, so I put here 3. And now if you simplify this, so this will be x square, this will be x4, so this become x6, and then here if you take cube, so this will be m power 3, and x power 2 multiply 3, it is x power 6. Now from here you can take x power 6 common, mushtarak. So then what is left here is 1 and minus square root 3 m power 3, and now this x6 and x6 will cancel, so we are left with minus 9m over 1 minus square root 3 m cube. Now again you can see here is no x, no y, and it is in M. So even if I apply the limit xy goes to 0 0, so it will not make any difference. So it means we get this. So for different values of M, again we get different answer. So therefore limit does not exist. So now your homework is part 2. I think you can solve this, so it's not difficult. You can easily solve this. Okay, our next lecture is partial derivative. So today in this lecture I will cover two topics. So one I already covered, which is limit, and the second topic I will cover partial derivative. That is why I call this lecture as lecture 4 and lecture 5. So now for lecture 5, find partial f over partial x. So this notation is partial derivative. You know, in calculus 1 you people studied total derivative, that was df over dx. So here is this sign is partial f over partial x, partial f over partial y, partial f over partial z for the following function. Now why we need partial derivative? We need partial derivative because now we are dealing multivariable function. So there are multivariable. So you can see here x, y, z, there are more than one variable. So there are 3 variable. In calculus 1 course there was only one variable. So that is why we are dealing a total derivative, that was df over dx. So so here we need partially derivative. So it means that is why we call this partial, because there are 3 variables. So when I want derivative with respect to x, so it means I need partially derivative with respect to x. Similarly, if I want derivative with respect to y, I need partial derivative. So I will find partial derivative with respect to z. So the rules will remain same. So whenever you are taking derivative with respect to x, so consider y and z just like a constant number. This is very important. So whenever you will consider partial derivative with respect to y, so then you will consider x and z just like a constant number. Okay, just like constant. So at that time it will not be variable because we are taking partial derivative. Now if I take partial derivative of this first function, so it will be partial f over partial x. So you know, derivative we are taking derivative with respect to x. So partial over partial x. So I have written here partial f over partial x and then partial over partial x of this all function. Now if you take derivative of x square with respect with respect to x, so it will be 2x, you know. And here is xy square. So we will not use here product rule. Remember, it is although x and y they are multiplying, but we are taking partial derivative. So it means here we will not use product rule. We will consider y square just like a constant number. So we need derivative only with respect to x, and you know the derivative of x is 1, and we write y square as same, because you know whenever some constant is multiplying with a variable, so we write the constant same, and then you write only the derivative of that variable. And similarly here x square z. Now you write derivative with respect to x square, so that will be 2x, and z will be just like a constant, so we have written same, and then derivative of 9 will be 0. So if you simplify this, so this will be 2x minus y square plus 2xz. So similarly I can write partial derivative with respect to y. So now it means I will consider x and z as a constant. So derivative of x square with respect to y, it will be 0 because there is no y involved. So here y involved, so you will write x same, and derivative of y square will be 2y, and here you can see no y involved, so 0, here no y involved, so 0. So if you simplify this, so this will be minus 2xy. Now again, if I need derivative with respect to z, so again it means now for me x and y will be just like a constant number. So I will write derivative with respect to z. So derivative of x square, again there is no z, so it will be 0. Again there is no z, so this will be 0. And here is z, and so the derivative of z it will be 1. So it will be plus x square, and derivative of minus 9 will also be 0. So the answer is x square. I hope it's easy and you can easily understand. Now we can solve another example, your third part. So your function is given as f of xy is equal to tangent xy minus z. So now derivative with respect to x of the tangent. So first we write the derivative of the main function. So the derivative of tan x is secant square x. So it means the derivative of tan will be secant square and same this x xy minus z. And then you write derivative of inside with respect to x. So the derivative of inside with respect to x, so derivative of xy with respect to x, so it will be 1. I have written here. So first you write derivative of main function, then you write derivative of inside. So inside is xy minus z. So derivative of xy with respect to x, it will be 1, and you multiply with y minus, and derivative of z with respect to x, it will be 0. So you can simplify this. You can 1 into y is y minus 0 is y. So you can write y first. So y secant square xy minus z. So that will be your answer. Now if I write derivative with respect to y, so the derivative with respect to y of tan xy minus z. So the derivative again you will write the first the derivative of the main function. So which will be secant square xy minus z, and again you will write derivative of inside. So derivative of xy minus z with respect to y. So it will be derivative of y will be 1. So you write x same, and derivative of z with respect to y it will be 0. So the answer is x secant square xy minus z. And similarly we can write derivative with respect to z. So again I write derivative of tan, which will be secant square xy minus z, and then again derivative of inside xy minus z with respect to z. So here is no z, so derivative will be 0, and here is z, so derivative will be 1. So your answer is minus secant square xy minus z. And so there is another example, f of xyz equal to x power 3 ln 2x square minus 3y square plus 4z square. Now this is even more interesting. Now here you can see there are two functions. One function is ln and all this, and one function is x cube, x power 3. Now it means when I will consider this with respect to x, so then I will use product rule, because here is also x involved, here is also x involved. But when I will consider derivative with respect to y, then I will not use product rule. The reason is here only y involved. This will be just like a constant, because we are talking about partial derivative. And similarly when I will take derivative with respect to z, so I will consider again I will not use product rule, because you can see x cube and here only z involved. So I will take x cube just like a constant, and then I will write derivative of ln, and then I will write derivative of inside. So first we write derivative of the given function f with respect to x. So derivative of this whole function with respect to x. So here I said we must use product rule, because there are two function x involved. So here x also involved, here also x involved. So you write x cube same, and then you write derivative of the second function, then plus you write the second function same, and then derivative of the first function x power 3. You can write derivative of this first this second, there is no problem. So x cube and derivative of, so you write partial derivative of this. So derivative of ln x is 1 by x. So first we write derivative of ln will be 1 over this all is just like x, and then derivative of inside with respect to x plus, and ln this you are right all same, and then the derivative of x power 3 is 3x square. So now you write x, you multiply x cube with 1, so this will be x cube over 2x square minus 3y square plus 4z square, and now partial derivative of this with respect to x. So the derivative of x square, it will be 2x, so 2 multiplied 2, it will be 4x. So here is no x involved, so 0, here is no x involved, so 0. So and this, now you can simplify 4x multiplied with x cube, so this will be 4x power 4, and plus this 3x square you can write first. So this is your answer. So this is derivative with respect to x. Now partial derivative with respect to y. As I said, here we will not use product rule, because you can see here we write x cube, it is written x cube ln this. So here in this x cube, and here is only y involved. So it means there is no need of product rule. Even if you use the product rule, the answer will be 0. Just like, okay, if I use the product rule, what will happen? X cube, you write x cube same, and then you write the partial derivative of the second function, plus you write the second function same plus into the derivative of the first function. So x cube, and then if you write derivative of this, so this will be 1 over this, and then derivative with respect to y, plus here you can see this partial or partial by with derivative, there is x cube, so the derivative with respect to y, it will be 0. So 0 multiply this, all will become 0. So that is why I said in the beginning, even if you directly write this step x cube and then derivative of ln, so that is fine, no need to do this use here product rule. But if even you use the product rule, you will get this answer. So now you write the derivative of this inside function with respect to, so derivative of ln is 1 over all this, and then derivative of this function in respect to y. So here is no y, so 0. Here is y involved, so 2 into 3, so 6y. Here is no y involved, so 0. So now if you simplify minus 6y multiply x cube, so this will be minus 6x cube y divided by all this. Similarly, I can find partial derivative with respect to z. So again, you can use the same product rule, or you can solve this direct. If you use the product rule, you write first function same, and then you write derivative of second, plus you write second function same, derivative of first, and we are talking about with respect to z. So here x cube, and first you write derivative of this with respect to z. So first there is ln main function, so you write the derivative of main function, so it will be 1 over this, and then derivative of inside, plus derivative of x cube will be derivative with respect to z, it will be 0. So 0 multiply this, all will be 0. So therefore we have x cube over 2x square minus 3y square plus 4z square, and derivative of 2x square with respect to z, it will be 0 because no z involved, 0, here z involved, so 2z, and 2 into 4 is 8z. So 8z multiplied with the x power 3, so this will be 8x cube z divided by 2x square minus 3y square plus 4z square. So I hope this is clear, and if it is clear, you can solve question number 3, part number 2, and part number 4. Still, if you have any question, any problem, we can discuss in our next lecture. Our next lecture, is on Tuesday and Thursday from 8 to 9 on Moodle. So I will be happy to answer your problem on Moodle. So please try to come live class in Moodle live class. So if you have any question, any problem, but first you must solve all these questions, all these homework. If you will solve this and then still you find any problem, we will discuss in our next classes. Okay, take care of yourself and have a nice day. Assalamu alaikum.